But quantum computing is still in its early stages, so these are long-term goals. Nevertheless, there are exciting intermediate milestones on the journey to building a useful device. One currently receiving a lot of attention is quantum advantage, where a quantum computer performs a task beyond the capabilities of even the world's most powerful supercomputers. Experimental work from the University of Science and Technology of China, USTC, was the first to claim quantum advantage using photons, particles of light, in a protocol called Gaussian boson sampling, GBS. Their paper claimed that the experiment, performed in 200 seconds, would take 600 million years to simulate on the world's largest supercomputer. Taking up the challenge, a team at the University of Bristol's Quantum Engineering Technology Labs, QET Labs, in collaboration with researchers at Imperial College London and Hewlett-Packard Enterprise, have reduced this simulation time down to just a few months, a speedup factor of around 1 bil. Their paper, The Boundary for Quantum Advantage in Gaussian Boson Sampling, published today in the journal Science Advances, comes at a time when other experimental approaches claiming quantum advantage, such as from the quantum computing team at Google, are also leading to improved classical algo. Joint first author Jake Bulmer, PhD student in QET Labs, said, "There is an exciting race going on where, on one side, researchers are trying to build increasingly complex quantum computing systems which they claim cannot be simulated by conventional computers. At the same time, researchers like us are improving simulation methods so we can simulate these supposedly impossible to simulate machines. As researchers develop larger-scale experiments, they will look to make claims of quantum advantage relative to classical simulations. Our results will provide an essential point of comparison by which to establish the computational power of future GBS experiments," said joint first author, Bryn Bell, Marie Curie Research Fellow at Imperial College London, now Senior Quantum Engineer at Oxford Quantum Circuits. The team's methods do not exploit any errors in the experiment, and so one next step for the research is to combine their new methods with techniques that exploit the imperfections of the real-world experiment. This would further speed up simulation time and build a greater understanding of which areas require improvements. These quantum advantage experiments represent a tremendous achievement of physics and engineering. As a researcher, it is exciting to contribute to the understanding of where the computational complexity of these experiments arises. We were surprised by the magnitude of the improvements we achieved. It is not often that you can claim to find a 1 billion-fold improvement, said Jake Bulmer. It helps us understand the bar we must get over before we can begin to solve problems in clean energy and healthcare that affect us all. The work is a great example of teamwork and collaboration among researchers in the UK Quantum Computing and Simulation Hub and Hewlett-Packard Enterprise. Story source: materials provided by University of Bristol. Note: content may be edited for style and length. Journal reference: Jacob F. Bulmer, Bryn A. Bell, Rachel S. Chadwick, Alex E. Jones, Diana Moise, Alessandro Ragazzi, Jan Thorbecke, Utz Uwe House, Thomas van Varenberg, Raj B. Patel, Ian A. Walmsley, Anthony Lawing. The Boundary for Quantum Advantage in Gaussian Boson Sampling. Science Advances. 2022. 8.4, doi. 10. 1126, SCIADV. ABL 9236. Cite this page. University of Bristol. Bristol team chase down advantage in quantum race. Claim speedups from optical quantum computers take a big hit. Science Daily, the 26th of January 2022. ift.tt/3ixxf2g. University of Bristol. 2022, January 26. Bristol team chase down advantage in quantum race. Claim speedups from optical quantum computers take a big hit. https://ift.tt3ixxf2g. Accessed January 26, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.